Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Derivation, we'll be looking at the 14th chapter of the grade 12 syllabus for physics in CBSE. Today the chapter is Semiconductor Electronics, Materials, Devices, and Simple Circuits, and we're going to be dealing with some more derivations and basically descriptions regarding this chapter. So today we'll have two of them, and they're quite big because you have to take construction and working, etc. So therefore they're quite big. So two of them are there in this video. The first description is to briefly describe a photodiode. In this you need to tell the construction, working, diagrams, and VI characteristics. So what is a photodiode? A photodiode is basically a special purpose p-n junction diode fabricated with a transparent window to allow light to fall on the diode, and it generates current when exposed to light. And this photodiode, it usually operates in reverse bias. So the photodiode is what we use as sensors. So light sensors are mostly made of photodiodes because when light of sufficient frequency hits a photodiode, then it can conduct electricity. So first of all, let's look at the construction of a photodiode. The photodiode is made of two layers of p-type and n-type semiconductor. The p-type material is formed from the diffusion of lightly doped p-type substrate. Thus, the layer of p plus ions is formed due to the diffusion process. Now, the n-type epitaxial layer is grown on the n-type substrate. So that means you have two layers, a substrate and a material layer for p-type, a substrate and an epitaxial layer for n-type. P plus diffusion layer is developed on n-type doped epitaxial layer. The contacts are made of metal to form terminals. So in order to form the cathode and anode, we make the contacts out of metal. So this is the construction of a p-n junction diode. So as you can see, in a semiconductor, you have an anti-reflective layer, and the exterior is made of silicon dioxide. You have an anode at the top and cathode at the bottom. The cathode is connected to the n-type, and the anode is connected to the p-type semiconductor. In between, you have an intrinsic layer. And here the light is incident on the anti-reflective layer, which is usually covered by a glass window. So In circuit symbols, the photodiode is represented as in this form. So there is a diode, and then there is light which is incident on the diode, which is represented by two rays. So now let's look at the working of a a photodiode. So working. If the energy of incident light, that means of falling photons, is greater than the energy gap of the semiconductor, electron hole pairs are created near the depletion region of the diode. The electron hole pairs created are separated from each other before recombining due to electric field E of the junction. The direction of electric field in diode forces the electrons to move towards the N side, and consequently the holes towards P side. As a result of the increase in the number of electrons on the N side and holes on P side, a rise in electromotive force. Electromotive force is observed. The more the electromotive force, generated, the greater is the current flow. Current flow so over here the magnitude of the current is directly proportional to the intensity of light. Now, if you look at VI characteristics, you can see that the reverse current is observed in a photodiode, and the photodiode reverse current is dependent on the intensity of light. So if the light intensity increases, then the reverse current becomes more negative, minus 100, minus 200, minus 300, minus 400, etc. Now, if there is nothing falling on the photodiode, then there is a normal current which is present in trace amounts known as dark current. So in a photodiode, the use is that the dark current is normally measured, and so therefore when light hits a photodiode, because of the forward bias and because of the reverse bias voltage and the formation of the electric field, there is extra current flowing through the diode, which means that an electrical signal can be generated if light falls on a photodiode. So therefore, photodiodes are used as light sensors, and also they can be used for electrical sensors such as the ones for IR, UV, etc. Now let's look at the next description or derivation. We need to describe briefly a solar cell. So over here again, construction, working, diagram, and VI characteristics. So we're talking about a solar cell. So a solar cell is basically a p-n junction diode which creates EMF when solar radiation falls on it. So a solar cell is the basic component of what is known as photovoltaics in general parlance. And first, let's look at the construction. Construction of a photodiode, of a solar cell, sorry. So for a solar cell, it is essentially a solar cell consists of a silicon p-n junction diode with a glass window on the top. The surface layer of the P side is made extremely thin so that incident light reaches the p-n junction easily. So this is the basic construction of a solar cell. And if you look at the diagram, you can see that the top part of the solar cell, this shiny bit, is made out of glass, and you have a metal rod which is placed on top of the P junction. So this is the P side and this is the N side, so you have a p-n junction as well. So the sunlight from the glass directly hits the p-n junction diode because the P layer is extremely thin with respect to the N layer. And both the P side and the N side have metal contacts in order to absorb the EMF and to create current. So that is how photovoltaics is used in order to create electricity. So a photovoltaic cell is connected to a resistance, so therefore you can observe current. Now let's look at the working of a solar cell. When the photons of light collide with valence electrons of semiconductor, at p-n junction, they produce sufficient energy to leave their parent atoms. Free electrons and holes are generated on both sides of the junction. Current is produced, which is directly proportional to two parts. The first part is illumination, so that means the amount of light itself, the intensity of light, and two, the size of illuminated area. So greater the amount of illuminated area, the more will be the current produced, the EMF produced. So when you look at the VI graph of an IV graph of the solar cell, you can see two things. Number one, the solar cell is an open circuit voltage because there is no EMF attached. There is no external EMF attached to the solar cell. The solar cell produces EMF of its own using photovoltaics. And since this is an open circuit and the current flows through it without any external EMF, the current that is produced is called a short circuit current. And in this graph, it is shown as having negative values. So that concludes this episode of Derivations. We hope you found this episode interesting. For more of such information and more derivations regarding various other chapters, you can always click the link in the description down below so that you can get the playlist and enjoy more of these videos. For accessing more of our useful and interesting content easily, you can subscribe to our channel, which is Brain Blitz Audios. So until the next episode, take care, stay safe, bye-bye for now.